Section 8.3 is on scale diagrams, and a scale diagram is basically a drawing which the measurements are proportionally reduced or enlarged from actual measurements. A scale diagram is similar to the original, which means it has the same shape but it's a different size. The scale would be the ratio of a measurement on a diagram to the corresponding distance measured on a shape or object represented by the diagram. A scale may be given as a ratio. For example, suppose the scale on a scale diagram of a house is 1 to 150. This means that 1 centimeter on the diagram represents 150 centimeters, or 1.5 meters on the house. A scale factor can be found, we're going to use K to represent the scale factor, and it says diagram measure over actual measurements. Sometimes that gets confusing, so I'm going to just change those words to match kind of with the rest of the chapter, and we're going to say the length of the image over your length of your original. So if you've got a side in the original and a side in the image, you can take the ratio of image over original to get the scale factor. So a scale factor can be written as a fraction or a decimal. Scale factor greater than 1 indicates it's being enlarged, and a scale factor between 0 and 1 indicates it's getting smaller, or a reduction. When determining scale factors, be sure to match corresponding sides. So you've got to match up the length with the length, the width with the width, and so on, or the right side with the right side, you know, the diagram is oriented the same way. So let's do some examples. So the first one there says, what is the scale factor for the diagram shown? So you should look at that and see that the original is small and the new one is bigger. So we're expecting to get a scale factor that's bigger than 1 because the new one is an enlargement. So if we do our scale factor is equal to what we're calling K. So it's the image length over the original length. And the image length, what we have to do is match up two corresponding sides. So I'm going to match this one with this one. So if we count 1, 2, 3, 4, 5, 6, 7, 8, image has 8 units, and the original has only 2 units, giving us a scale factor of 4. And that matches what we thought, because we were expecting it to be a number bigger than 1 because it's an enlargement. Next example says, what's the scale factor for the diagram shown? Now this one looks like it's being reduced. We're expecting a scale factor that's smaller than 1. So if we take the K value for our scale factor equals the image length over the original length, we get the image, use this side, would be 1, and the side that matches up within the original would be 1, 2, 3, 4, 5. So it'll be 1/5 or 0.2. And that matches what we thought, because it is a scale factor that's less than 1. Question number 3 says the diameter of the animal cell that is represented by this scale diagram is actually 0.25 millimeters. Oops. 0.25 millimeters. What scale factor was used to draw this scale diagram? So the one thing I do notice here is that what they gave us for the original is 0.25 millimeters, but on our image here we have 3.5 centimeters. So one thing I would do first is I'd probably change both of those to the same units. Now there are 10 millimeters in 1 centimeter. So most of you might find it easier to change 3.5 centimeters to millimeters, which is 35 centimeters. Millimeters, I'm sorry. 3.5 centimeters times 10 would be 35 millimeters. So therefore our K would be the image over the original length again. So this time we have the image diameter over the original diameter. So the length of the original image diameter over the original diameter would be, in this case, the image diameter is 35, and the original was 0.25 millimeters. So 35 divided by 0.25 is 140, a scale factor of 140. And that makes sense because that would be an enlargement. What we have here, the image that we have, is an enlargement of the actual cell. The next example says to apply a scale factor of 0.25 to the diagram below. So we're applying a scale factor of 0.25 to each side in this diagram. We would actually be reducing the diagram because the scale factor is less than 1. And all we need to do is take each of the sides. So I'm just going to draw a smaller one just to represent. It's not going to be, I'm not going to use a ruler on that, but if technically we were doing this, you should use a ruler. So the side that's here, the new side would be 6 times 0.25, which would be 1.5, I think. Yes, so that would be 1.5 centimeters. So that would be 1.5 centimeters here now. And as would this be 1.5 centimeters, and this down here, because they're all originally 6. Then you'd have the ones that are 4, would be 4 times the scale factor of 0.25, would equal 1 centimeter. So this would be 1 centimeter, this would be 1 centimeter, and 2 times 0.25 would actually be 0.5. So this would be 0.5 centimeters here, 0.5 centimeters here, and 0.5 centimeters here. I forgot to show my work for that. 2 times 0.25 would equal 0.5 centimeters. Question number 5. A photo has dimensions 9 by 6. The photo is to be enlarged by a scale factor of 7/2. Calculate the dimensions of the enlargement. Well, if you know your scale factor, then the new, if we look at our formula, K is equal to the image over the original. Then if we kind of consider cross-multiplying that, the image length should be K times the original. So if we look for the new width, it should be 6 times 7/2, which is going to be 42/2, or 21 centimeters. And then the new length is going to be 9 times the scale factor, which is going to be 63/2, which is going to be 31.5 centimeters. Question number 6, this says a circle has been transformed so that its image radius is 14 centimeters. If the scale factor is 0.4, what's the radius of the original circle? So again, we go back to our formula. K equals image, in this case the length is a radius, image radius over original radius. And we know that the scale factor is 0.4. We know that the image is 14. So we're looking for the original. So we put X in there. And then once you've got that done, you can just put this over 1 and cross multiply. So X would equal 0.4X, 0.4X would equal 14, and then to get X by itself, you have to divide out the 0.4. Which means X would be 14 divided by 0.4, which would be 35 centimeters. And that makes sense because it said that the image was 14, so the image, if the scale factor was 0.4, the image should have a radius that's less than the original. So this would be the original radius. Great. Question number 7 says ABC, triangle ABC is similar to triangle STU. If the sides of triangle ABC measure 5.2, 3.8, and 6.4 respectively, and the scale factor is 2 to 3. So that can be written as 2/3. what is the perimeter of triangle STU? So we would have, basically that's our scale factor, so then 5.2 would become 2/3 of 5.2. So that's 2 times 5.2 divided by 3, which is going to be 3.47. We round it off, and then the 3.8 becomes 2/3, the scale factor, times 3.8, which would be 2 divided by 3 times 3.8 is 2.53, round it off, and then the 6.4 would become 2/3 of 6.4, 2 divided by 3 times 6.4 is 4.266, so that would be 4.27. So those would be the new sides, so the new perimeter would be the total of those added together, 3.47 plus 2.53 plus 4.27. And that would give you 3.47 plus 2.53 plus 4.27, which is 10.27. And doesn't say what units it is, centimeters or not. Okay, so those are some questions there that you can try, listed at the bottom there for that section. And there are questions in textbooks that you can try for extra practice.